Instrument which you are going to perform is Lyoid's mirror by obtaining the interference fringes by using the Lyoid mirror. You have to determine the wavelength of a given source. So this is a source of a light. Sodium source is given, and the Lyoid mirror is given. So by using this, this is a Lyoid mirror. You can see it is a plain glass, polished at the front side and blackened at the back side. So this is a polished surface. Now here on this Lyoid mirror, the beam of light, when you open the slit, this is an optical bench. All of you are aware optical bench, you might have done in S1. So this is a slit stand. This will call as a Lyoid mirror stand now at present. Here this stand we will use to mount the convex lens, and this stand will be the eyepiece stand. Alright, micrometer is there. This one. Now open the slit, the light will come, it will fall on the surface of the Lyoid mirror at a grazing angle, and then it will get reflected. You will be able to see the virtual image of the slit in the mirror. That virtual image and the actual slit, these two will act as two coherent sources. The rays which are coming from them, they will interfere with each other, and you will be able to see the interference pattern. So you can see this. This is the beam coming directly from the S1, and this is the beam which is reflected from the glass Lyoid mirror, and here the interference pattern you will be able to see. That is the interference pattern produced by the Lyoid mirror, and by using that pattern you are going to determine the wavelength of the given source. That is the aim of our experiment. Right? Now here these fringes you can see. You can see the fringes. Now here I have obtained the fringes already. You can see one by one. Alternate dark and bright fringes equally spaced. Alternate dark and bright fringes. Alright. Now here how to obtain? Open the slit. See the image of the slit. The two slit and the image of the slit will be visible. Then initially keep the width of the slit open, wide open. Then decrease the width of the slit. Bring the two image that original slit and the image of the slit close to each other, and just adjust the position of the this micrometer, so eyepiece, so that you will get the pattern visible. Alright. If you are not getting it, adjust the position of the Lyoid mirror, adjust the plane of the slit. So this way you will be able to get the fringes. This is a trial and error. You will require a time to obtain them. Practice it, definitely you will. Now once you get the fringes, the next step will be what? You have to find out the least count of the micrometer here. Now here you can see this is the main scale and this is the circular scale. Now here this sheet is given to understand how to take the reading. Then the least count of the micrometer, smallest division on the main scale here. So here you will call this as 0, 1, 2, 3, 4, 5, 6. Right? Then each 0.1 centimeter distance is divided into half. So what is the smallest division on the main scale? It is 0.05 centimeter, and divided by circular scale divisions. There are 100 circular scale divisions. So 0.05 upon 100 means 0.555, 0005 cm. This will be the least count of the micrometer. Have you followed how the least count is obtained? Then how to take the reading? Now see this picture. Here the same. Here what is the reading now? This is a 0 here. Where this 0 correspond? You can see here I will call it a 0, 1, 2, then 2.5, 6, 7, 8, and one more small line is there. So therefore it will be 2.85 main scale. Have you followed how to note the main scale reading? If completely visible, then only call it as 2.85. If it is partially visible or it is not completely visible, then you don't count it, because that extra distance will be counted by circular scale. Got it? Then circular scale, what is the reading here? It shows here 95. This 0. Which one? This. Where it corresponds, that you have to see. So here see, in the example it is 95 into 0.0005. So 95 into 0.0005 is this. Your main scale reading is this, total reading is this. So take any fringe on the cross of the cross wire or on the vertical line of the cross wire and take the first reading, first band fringe you are noting the reading for that. Then you will go for the second fringe, you will go for the third, where you have to tabulate. Here least count you will note down. Then here first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11 and 12. Now this is the first fringe, this is the seventh fringe. The difference between these two will be the fringe width for the 6 bands or 6 fringes. Here it is 2 and 8, this will be for 6. 3 and 9 for 6. 4 and 10 it is for 6. For all the 6 fringes fringe width you will get. Now add it, take the mean of that, divide by 6, you will get the fringe. So first part of the experiment to determine the fringe. Now all the fringes are equally spaced. So whenever you will get this reading, they should be near about same. All not exactly same, but near about same you should get. If you are not getting it, you check your alright. Got it? So first to second, second to third, third to fourth, like this way one by one you will go. And with proper precaution, accurately you note down the reading. If you note it accurately, you will get the your bandwidth correct or the fringe width correct. Then you know the formula, lambda equals to x d by d. X you got, d the distance between the slit stand and the IP stand. Slit stand is here 0. This is the IP stand. The distance you note down first. Before starting the reading you note down. Otherwise, if you forget it, then you will not be able to press note down it once again back. Because in the second part you are moving your IP stand. So therefore you should note it first. Now here this will be d dash, and then you will remove the optical bench error we have to count, and then you will get the d. And this small d, the distance between the two virtual sources, that is denoted by small d, that you will obtain by obtaining the magnified and the diminished image of the pattern. So that I will show you how to obtain. You will take a convex lens, you will mount it here and get the magnified and diminished image of the pattern, and then measure the distance between two magnified image, that is d1, measure the distance between two diminished image, that is d2, under root of d1, d2 will be d. So like this way small d will come, then x you will get. Now capital D you on by using that glass rod, you have to remove the optical bench. You have to determine the bench. Glass rod will be given. See the image of the board. So capillary is there. The image of that capillary board you will be able to see. Mount it here. Remove this. Everything you will remove in the third part. See the image of that board. When you will get the clear image, measure the distance between the slit stand and the IP stand. Measure the actual length of that rod, which is given, glass rod, and then difference between that you find out. And here the way is given how to find out how to note down the determination of bench error. L0 difference, and whatever will be the bench error will come, that you have to add to d dash plus that bench correction you have to add. So if it is 30, 40 suppose, and if your difference is coming 5, you have to add that d dash plus d 5, so means it is 40. So I will show you that when you come to the third part. Now at present your first part is ready. You start taking the readings. Complete first part, second part, third part, and then you can practice for fringes. Got it? So this is the way. Once you know x, small d, capital D, you will be in a position to find out the wavelength of the source. It is a sodium source. You know the wavelength of it. So whenever you will get the answer, you can verify what is the answer expected. Alright? Then error correction is also there. So that you can find out by using this formula. Delta lambda by lambda equal to delta x by x plus delta d by d plus delta d capital D by. Here error in the fringe width upon the fringe width. Then d, the distance between the two virtual sources, delta d, the least count of this micrometer 0.0005. Then capital D, least count of this scale of the optical bench upon D. D is the distance. This. Alright. You will measure this distance and a bench error you will add that. And then substitute it multiplied by lambda delta lambda. Alright. So you will have to write the result. The wavelength of a sodium source by performing the Lyoid mirror experiment and studying the interference of fringes, lambda plus or minus delta lambda. That will be the result of the experiment. So have you got it? You can start performing first and then you can practice further. Yes?